And now I'd like to cover the tracking generator. Tracking generator is an option available for the DSA-815 at the time of purchase. It's a factory installed option. You can see that this particular 815 has tracking generator output. The tracking generator output, for those of you that aren't familiar, is a frequency scanning RF source with an adjustable amplitude. And so if we're scanning from 9 kilohertz to 1.5 gigahertz and we enable that tracking generator, we're going to have an output. In this case, it is set to 0 dB. So we're going to have a 0 dB output tracking along that range of frequencies. It can be helpful if you're going to be testing amplifiers, filters, as well as making VSWR measurements on antenna. You're going to need a tracking generator for that. A very popular option. And next we can move on to the measurement capabilities. These measurements are all optional. Oh, I'm going to turn off the tracking generator. Let's go to measure. So some of the measurement capabilities that we have an additional option for VSWR measurements. That's a software and hardware option. In the VSWR measurements, if you're going to be measuring the VSWR for antenna, you can. This makes that mathematics makes the math quite a bit easier and displays the VSWR on the front panel here for that particular antenna. Let's get back to measure. We're going to disable VSWR, and that is available again as an option, DSA-800 VSWR. Then we also have a DSA-800 model AMK, or Advanced Measurement Kit, and that comes with total power. That comes with total power, adjacent channel power, occupied bandwidth, emission bandwidth, carrier to noise ratio, harmonic distortion, CN ratio, harmonic distortion, and third order intercept. So those are some of the available measurements for the AMK option. The 815, let's get back to the main page. The 815 also comes standard with demodulation as AM and FM demodulation. I'm going to turn off the demod. Hold on. All right. We also have storage capability. Storage, you have a number of user presets. The user presets are going to be, so we can select different file types, and that is going to be a filter on the functions that we're looking at, or on the files that we're looking at, or directories. We could also adjust the directory or the file type, and we have the ability to then save. If we're saving traces, we can save those in binary format, which is going to be used by the DSA to display the data, or as a CSV file if you wanted to take that trace data offline and save that to an Excel spreadsheet or something similar. And we also have the ability to recall, rename, delete, copy, naming prefix. You can set a naming prefix that will be used for all of those file types. And we also can perform system updates or firmware upgrades this way. I'd also like to show one of the more convenient features. I'm going to take a USB stick and install it. It's going to get recognized by the system. And as soon as that gets recognized, we can then press the print key over here on the left-hand side. And that's going to bring up a file save menu. We can then press a key to give that a file name and then enter. And now we're actually saving a bitmap image of the whole display, as well as the menu and all of the settings that we have available to us, and that's getting printed directly over to that USB stick, which can be extremely helpful if you're writing reports and you want to be able to put images in for the scans that you're taking a closer look at. Now let's take a look at some of the marker capabilities. Marker is going to give us the amplitude value at that particular frequency value. Here we have a marker number 1, and we can see we can move that around to different points on the trace, and it will give us a different frequency value and a different amplitude value. The available markers, we have 4 available markers that are either normal or delta pair. We can do span pairs. We can do marker trace. We can also do readout frequency, period, delta time. Marker table, if we had a number of markers available, we would then see all of them available on the bottom of this marker table, or we can disable all of them. Markers are helpful when you want to measure the different points between peaks on either 1 or 2 or multiple traces that you have available on the screen. It can be very helpful for measurement. I'll look at some of the other markers that we have available. Marker function, we have noise markers, which are going to be able to give us the value for the noise at a particular level. So dBm per hertz, we can select the bandwidth. We can select the bandwidth here, and you can see the bandwidth is then indicated on the display. We can turn that function off, of course, and then we also have a frequency counter. So at that particular value, at the particular marker value, we can measure very accurately the actual, we could set the resolution to measure that accuracy of that frequency count in that particular area. Similar to the marker function is a peak function, and the peak, we can actually select the next peak value. In this case, we don't have a peak shown, but peak is going to be determined by whatever search parameters we have. So you can set a particular amplitude value and a threshold that determines or defines what a peak is. Once you've defined what a peak is, you can use these quick keys, next peak, peak right, peak left, to be able to search through the individual peak values. And to go along with that, it's very similar to a marker. We have a peak table. A peak table is then going to show us all of the peaks that have been established or have been determined based on what we've defined the peaks to be. And that can be helpful if you have numerous values for each trace that you want to go through very quickly. You can use the peak and peak table in order to be able to take a look at those. Now let's take a look at some of the more standard functions that we can help configure the instrument. If we press the system key, you can see we can choose a number of languages available. We also have the ability to reset. We can actually power on either in the last user setting, or we can do preset. Again, the preset key is over here. We can set the preset key to factory defaults or a number of user-defined states for the instrument. We can also calibrate. The instrument will, and the factory defaults will calibrate periodically during the self-cal, or we can force a calibration, or we can disable the calibration if we wanted to. It does periodically happen. If you have an automated test, you're probably going to want to force calibration prior to doing the test, turn calibration off during the test so that it's not interrupting to get a faster throughput, and then enable a calibration scan after that. You want to minimize the time between calibrations to maintain a high level of accuracy. I/O settings, we have a number of I/O capabilities with this box. We have USB, LAN, as well as a GPIB to USB adapter, and you can then select what GPIB address you're going to be using. And now let's go to the display. With display, we have a display line that we can activate. The display line is shown here. Display lines can be used for pass-fail, can be used to set baselines, and be able to highlight or indicate an area that you want to focus on. We can move the active function. In this case, we have display line. We can set it to top, center, or bottom if you wanted it out of the way. We also can set the gradical brightness. We can disable the screen. We can also set the trace brightness. We can enable the user key. User key is over on the right-hand side. Basically, when you enable the user key, you can set it to go into an area as a quick jump to that menu. So if we disable the user key, now let's enable the user key, and let's go to measure, and we'll enable VisWar, and we'll press the user key on. And so now you'll see that if we press the user key, we'll go back to the VisWar. So let's turn off the tracking generator, and let's turn off VisWar. And now we're going to just go back to the standard menu. And now if I press the user key, you'll see the tracking generator comes on and the measurement key comes on. So it's a really nice way if you have a common process that you always go back to. You can define that user key to be able to configure it to enable a whole lot of options very quickly and not have to dig through so many menus. I'm just going to get back to a standard state here. We get back into the system. We were in display, so let's jump back out. And now let's take a look at work setting. Work setting is we're going to be able to disable the front switch. Right now, as a default, factory default, when the instrument is powered off, you have to press the power switch to turn it back on again. Or if power from the mains is cut, you're going to have to enable it using the power switch. Front switch allows you to disable the power switch such that if mains power cuts off and the instrument is powered down, when mains power comes back on, it will enable itself again and start back up. If you have an automated test stand and power cuts to the automated test, the instrument will actually power back up if you disable that front switch. Line mode, you can select again you can select your user settings or states for the instrument, and then you can enable or disable the user key. Then we can go on to system information. Again, we're on page 2 for the system file. System information is going to give us versions of the boards as well as any firmware and any errors that we may have. We also have self-test, which allows us to test screens or keys. Time and date, we can set the system time and date. Licensing, again, we have a number of options that are available. You can select the option information and it will tell you which options you have enabled. You can also install options from this screen. We have a convenient educational tool called the TX1000. That's an RF demo board. The DSA-815 can actually operate that board directly from the front panel. It has a number of software switches that we can run and a number of different components from an RF standpoint that would allow us to do some pretty neat tests. Again, you can run the TX1000 directly from the front panel. And so I did take a little bit of time to configure the instrument for a presentation of its lowest DANL, basically the lowest noise level that we can measure with this particular instrument. So I'm not going to go into a lot of the details of the settings necessarily. They're available in the specifications or the user's guide for the DSA-815. But you can see I'm running an active scan here, and my reference level is -30 to -160, but the noise level is below 135 dB. So that's a very good DANL for a box of this type. And finally, I'd just like to cover a few more of the options that we have available. Software options, again, these can be upgraded at any point in the future. If you purchase the DSA-815 and you want to upgrade later on, absolutely no problem, just give us a call. That would be the advanced measurement kit. That's going to contain a lot of convenient measurements for total power, adjacent channel power, etc. And then VSWR, an available RF coupler and bridge. That's going to be DSA model or DSA-800 VSWR, and that's going to be a convenient way of showing the VSWR measurement for an antenna on the front panel or the display. Also available in the software area is an EMI toolkit that features an EMI filter, quasi-peak detector, and it also gives you some FCC resolution bandwidth values for qualification of FCC testing. Again, very good tool for pre-compliance testing. We'll have some follow-on app notes in that area as well. Some hardware options that are available. Tracking generator, that's a factory installed option, so you do need to order that at the time of purchase. And then we also have a GPIB to USB converter if your application requires that. Thank you very much. I hope that you found this tour to be helpful. And if you have any questions, you can always give us a call or drop us an email. Thank you very much. Take care.